Welcome to this topic on fuel for the Airbus A320 family. This is going to be an overview and familiarity with the fuel system and the tanks in particular. We're talking about the fuel tanks and all the related components to that. Also the circulation of the fuel and distribution of that fuel to the engines. And then we're going to be looking also at some of the controls and indications that we have in the cockpit. And what kinds of warnings can you expect to see on the displays? So we're going to be looking at all of these different things. Now, to give you an overview of systems that we have, besides as far as what makes up the fuel system, okay, obviously we're talking about fuel to the engines, but you know, the fuel flow to the fuel tanks. And please keep in mind that of all the different topics that we talk about, safety is always something to be mindful of, no matter what systems that you're working on the aircraft. However, this has an extra safety kind of heads up, is the fact that you can have an explosion with fuel, obviously, because it's flammable. So that's one of the things that you want to be aware of, and do follow configuration. Design configurations. There are some items that are specifically designed away, and you must follow the AMM, you know, to the letter, because of the potential. If there's wear or damage to any of these items, okay, these parts, when you're doing installation, then there's a risk. You know, there's a potential there for having a fuel tank explosion. So I can't stress enough the importance of being more mindful when it comes to any kind of maintenance that's done on the entire fuel system. And obviously, you know, we're involving the tanks, the fuel tanks, under that kind of pressure and, you know, just that potential for an ignition. Okay, so like I was saying, the most important thing is going to be like location of where these fuel tanks are. And the different kinds of systems that we have related is going to be your indication system. And, you know, with indicating what, we're talking about a fluid. So we want to look at quantity, pressure, and temperature, right? And also your refuel, defuel system. And the operation itself as far as distribution to the engines and getting that fuel distributed. And then the venting system. And the transfer system. Okay, so let's start with the locations. Where can we find the tanks? Now, on the Airbus A320, it's going to be for 18, 19, and 20. There are going to be some changes a little bit when we come to 21. I'm talking about the Airbus A321 model. But when we talk about the A320 family, we're talking about the 18, 19, 20. And just I'm going to say for the most part, okay, I'm saying that because they're actually identical, but I want to say just always follow the AMM for that particular aircraft that you are doing maintenance on. Okay, that's a definite thing. So with that said, the fuel that gets distributed to the engines, okay, as well as the fuel that you know, gets distributed, it's also being used to kind of cool the temperature. So it's applying the fuel, and I'm talking about the fuel system itself, is used to control the temperature of the engines. Okay, so that fuel, by just getting there, is also kind of cooling things some, as well as cooling the oil for the IDGs. So just an added function. And then of course, you know, you do have your indications in the cockpit. So we'll look at, you know, your normal operation and what indications do you have there. And then when something's not right, what indications are we going to have in that situation? Okay. So with the tanks, and remember I said there's 6, they're actually operated by pumps. So you have a pump, you know, for each tank. Now, the ones in the center, okay, so the two in the center tank, those are depending heavily on that pump. So if that pump fails for whatever reason, it's not going to be able to get that fuel distributed to the engines. So just kind of keep that in mind. That's your auxiliary. I know back in the day, that was like what, 30 or something years ago, is that, you know, that center tank is really supposed to be an auxiliary tank. Your main ones are going to be on the wings. So just to let you know about that, there's no backup, if you will, if that pump fails. Now you do have a kind of a backup, or the way it's configured and designed is that if for some reason the pumps for the fuel tanks that are on the wings, okay, so those wing tanks, if for some reason those fail, there's a way for the engine to actually, get that fuel. It's a suction effect, and it's actually going to kind of feed itself. It's going to find a way to get that fuel, but it can only do that from the fuel tanks on the wings. Okay, and then just that's kind of the mechanism with the distribution as far as the engine receiving the fuel. And then of course you do have a cross feed valves. We'll talk about different valves. The valves that are involved here in the fuel system, you've got the cross feed valve, which if you recall from previous topics and lessons, the cross feed valve is just allowing to either isolate or not isolate. So you can isolate the fuel tank so that it's fueling the right engine if it's the right hand wing tanks, or the other side. Or if for some reason there's a desire to have the fuel tanks servicing the opposite engine, then that's that's able to do that as well. And then you also have the low pressure shutoff valves. Those are going to actually be in effect when the fire push button's released, because you don't want to have fuel continuing to flow, right? When there's a potential fire, you're just going to add fuel. You're adding fuel to the fire, right? So you don't want to have that. So there's that low pressure shutoff valve. Those shutoff valves are going to be shutting off that fuel to the engine. Okay. The other thing I mentioned about your different systems, okay, so you have indication system, is you also have a venting, your venting system. And the venting is allowing, and I don't know if you understand from, I don't know, I mentioned this in hydraulics before, and basically what it is, you're creating an equalization of pressure, because there's pressure in the tank in order to, and it's constantly being monitored, because you want to make, as fuel's being consumed, you're having now space, okay, that where there was fuel, there is no fuel in that particular section, whatever, in the tank as it's being consumed. So there has to be an equalization with the pressure on the outside of those tanks, or the atmospheric pressure. So what we have is a venting system, and it's just allowing kind of a venting to the atmosphere through the vent tanks. Okay, and you have the vent tanks are located on the outer ends of the wings. Okay, and so you have those there for that purpose. You also have there's a refuel defuel system. The refueling defueling system is just it's controlling that flow of fuel. Okay, so that's the aspect of the fuel system in general, where we're talking about controlling that flow of fuel going into or out of the aircraft. Okay, so there is a control panel for that. There's a pre-selector. Just follow again procedures on how to refuel. And then you also can, of course, remember I mentioned about quantity, temperature, and pressure. The quantity indicating system, the FQIS that we have here, typical capacitance type indicating system. If you don't understand what that means, let us know, but that's pretty standard across different indication systems. Now, that's for in flight. If the plane's on ground, so you have a grounded plane, and you want to do some kind of measuring of that fuel quantity, you're going to have the MLIs be there. So you have magnetic level indicators that are going to give you that reading for what the fuel quantity is. And you have that in the left wing, right wing, and also the center tanks. And like we have in just about everything that we mentioned, we have control units. So you have the same here. There's a fuel level sense control unit that's going to be able to basically manage that quantity indicating system, so it can make sure that there's enough fuel, etc. And again, I'm going to stress again the importance of paying attention to your AMM when it comes to working with fuel. Fuel is extremely dangerous in a nutshell, and so just you want to be a little bit, again, just have a higher level of awareness when you are working with this particular system. And like I said before, there are certain parts that are deemed pretty critical, so they have to be handled and installed, etc., in a certain particular way to avoid the potential of an explosion. Okay, so that kind of gives you an idea there. Now, as far as the quantity, and just, this could vary a little bit, but in giving you an idea that just across, when you look at your total capacity, so 246, right? 2 on each wing, 2 in the center. So you have your center tank. Amongst all of those, when you total that, it should be about 42,000 pounds of fuel capacity. There's just some different measurements with fuel. In this particular case, I'm having to mention it in terms of pounds. Okay, so 42,000 pounds. Each of your wings are going to be holding about 12,000 pounds or so. And then, of course, the center one, okay, or excuse me, that's your inner cell, and then your outer cell, because the way that the tanks are, you have an inner cell and an outer cell. And so the inner is going to be containing the majority of the fuel, and then the outer cell has roughly about 1,500 or so pounds of fuel. So, and the center tank is holding about 14,500 pounds of fuel. Okay. So remember I mentioned it a bit ago about the outer cell and the inner cell. The inner cell being that it holds a lot more than the outer cell. So the outer cell is going to be filled first, okay? Then it's going to spill over into the inner cell. All right. Okay, so that's with your fuel tanks and the nature of the wing tanks, the way they're structured, as you have an outer and an inner cell. And then you also, of course, have have water drain valves, because you want to make sure that water doesn't just stay in the tanks. So you got these water drain valves that are there, and that's just to allow manual sumping of the water out of those tanks. Okay. You also have clack valves. Those are installed also as part of a cell around the wing pumps. And they're basically allowing the fuel to enter, so it's have to do with refueling, but not to actually drain out. Those clack valves are kind of one-way valves. And then, you also have these surge tanks. Remember I said that you have the vent tanks at the outer edge of the wings. Okay, so those vent surge tanks are going to, keep that fuel tank open to the external air pressure. Okay, so remember what I said about pressure is very important, and it's constantly changing. Okay. All right, because you don't want to have a disparity that's really large as far as you don't want to have your differential pressure to be too much, because then you're going to cause damage to the aircraft. So it's just physics is physics, guys. All right, so, and just kind of a little tip here, and please keep in mind that we're going to have an update, a kind of like updated, kind of a casual form, if you will, to the GenFam. So after you're done with all the different topics, we tend to have at the end, and we recommend you obviously choose this one as the last one that you open up and access, is having our aircraft mechanic and a couple of aircraft mechanics that we have at work with us, and also our our pilot, so that we can kind of have a discussion and about just some of the tips that are out there. Again, always follow the AMM, but it does help to hear it from the other, very experienced mechanics who might be able to help you just improve your maintenance skills and abilities just a little bit, okay? At least a little bit. All right, so because I mentioned about the installation of the water drain valve. The water drain valve, like I mentioned earlier, and we know what it's for, but that's just one example of one of those items, okay, or part, it may be referred to item, but that actually is important to pay attention to. Because those water drain valves can also be a source of ignition, okay, in that tank. So you want to be very careful with the handling of water drain valves and making sure there's no damage or wear to those things. Okay, and there's kind of a a kind of a breakdown layout in the kind of in a like outline, giving you kind of the lay of the land, if you will, with the fuel tanks in the wings and the fuel tanks that are located in the center. And then where you have the transfer valves as well. So you have the transfer valves. And of course, like all systems, you've got your sensors. We'll get into more on the, I say computer, because there's going to be a computer here when we talk about the fuel indicate quantity. All right. So it gives you an idea about the tanks, okay, and how they're structured, outer and inner cells. And the controls and indications, we're going to talk a little bit more, but it's, we've got fuel quantity. We want to make sure, the quantities is where it needs to be. And also just a little bit more, or a little talking about the valves. So let's just go a little bit into the controls and indications that we have. And then I want to start going into the different systems. Okay, so we'll look at distribution in a little bit more detail, but I want to hit the systems after talking about the indications and controls that we have in the cockpit. So with here on the overhead panel, 40 VU in the cockpit, you've got the control switches and the indication for the engine fuel pumps. Okay, now those two selections for that, you've got auto and you got manual. And of course you also have indications for your cross-feed valve. And those are all located on the 40 VU panel. Now, there's the fuel control panel, and that's on that 40 VU. Now, above that, you're going to see the push buttons for the engine and the APU fire buttons. So you got engine fire and APU fire push buttons, which is important. Remember I said you want to shut off fuel if there's, indication of a fire or, something related that, we don't want to have a continued flow of fuel when there's that situation. So those push buttons are located right above the fuel control panel for convenience. And so again, it's going to basically be, those are the shut-off valves to shut that flow of fuel. Now, besides on that panel, you're going to also see the displays on the ECAM. Right, so ECAM's going to show different things. The ECAMs has a fuel page, just like we have our HYDE page for hydraulics. We have the fuel page for fuel system, and that's going to show different things. Obviously, your fuel flow and distribution. Also, it's going to show what's been consumed already by each of the engines, and your temperature, of course. Your inner cells transfer valve position. That's important, and then your fuel quantity in the center tank, okay, and also in both in the tanks for both wings. So that's what that fuel page is going to reflect on there. Now your total fuel on board, that your FOB, is also going to be showing. It will be showing though on your engine warning display. Okay, and also and the fuel page. So in addition to it being on the fuel page, it will show up on the EWD. Now, I've covered this, I know, in another topic, but about the cross-feed valve and, what kind of indication does it, what does it look like with the indication. So it's a circle. Okay, so it's a circle. And remember I said when things are horizontal, things are good. So kind of a thumbs up. That's what I'm doing right now. So when I say that, it's going to be green, because green means everything's good. So green and horizontal, that means the valve is open. Now, of course, it depends on what kind of valve and the function of that valve as to whether or not is that supposed to be open or closed. And if you recall from one of the other topics, that was kind of, these were test questions, because you have to understand what's the I say the natural, but quote unquote, but kind of the expected normal condition of that valve. Is it supposed to be open or closed in just its natural, original state? And then if something else happens, then it should either open or close and basically do the opposite of its original state. So here, when we talk about the cross-feed valve, the green and horizontal line is going to indicate that the valve is open. Okay, so normally be closed. If it's going to need to be opened, or it's desired for it to be open, then you're going to have that green horizontal line. So you have that crossfeed valve indication circle with the green horizontal line. You also have an amber colored either horizontal or a vertical line or a slanted line. So if the amber color shows up, the amber, if you look at the line, look at the position of the line, okay, on the indication, if it's slanted, it's going to be in, that means that valve is in transit. If it's vertical, then that means that the valve is closed when you have that crossfeed push button on. So when crossfeed button is pushed in or in the on position, then and you have the amber vertical line, that means the valve is closed. Okay, now what if it's amber but it's a horizontal line, not a vertical line? Okay, so that's going to mean the opposite of the it's closed, right? So you have the horizontal line is going to indicate, okay, remember amber horizontal is going to mean that the valve is open with the crossfeed push button selected and off. Okay, and you can see from the slide, we're going to have, again, refer to it. I know some of you are great at hearing someone, so you have it auditorily. Helps to have visuals, so the handouts are going to help, and any of our slides that you can see the bullets and kind of the listing of the different points that I'm making. Okay, so all right, so that gives you kind of a rundown a little bit on the controls and indications that you'll expect to see in the cockpit or the pilot. If you're doing maintenance, and you're doing checks, you're going to see those types of things on there. All right. Now, since we talked, we were talking about the controls and indications, and one of those indications is the fuel quantity. Okay, so very important, right? We want to make sure that the plane has enough fuel. We don't want it to run out. So this here, very important, is we're going to look at the fuel quantity indicating system and kind of see what different things that we have as far as the display, and what we need to expect. Remember, this is what I mentioned earlier about how I'm going to be mentioning a computer. Okay, well, here it is. Okay, I mean, there's different control units, but here, when we look at the fuel quantity indicating system, we're going to be involving a computer system. So with this system, it is computerized. And what is this system doing? I mean, the obvious thing is it's, measuring fuel quantity, so we can know if we need to, put some fuel in. So here it's going to be looking at the mass temperature measurement. It's also going to be, the system itself is going to be monitoring itself. Remember I said a lot of these computers they're already designed to check for its own, like to make sure it's functioning. So it's also using byte to monitor itself. It's just the way it's designed. You also have the attitude data that's received through the air link, and that's during flight. That's all coming from the airs, and that's going to be used as an alternate source of the attitude data. Okay, and then again, also the control of automatic aircraft fueling. So that's part of the quantity indicating system, is providing all these different functions. Now, what components what components are involved with the fuel quantity indicating system? You have a pre-selector. I mentioned that in the beginning, but we have a pre-selector. There's also fuel probes, because I mentioned, if you see a diagram, we see something, there's going to be sensors sensing levels, and when something gets to a certain level. So do we have those sensors? Those fuel probes are part of the fuel quantity indicating system. You also have the condensicons. You've got a computer, and you have a multi-tank indicator. Okay. Now, there's two channels. Okay, two channels to the FQIC. Okay, your fuel quantity indicating computer, and that's going to control the system. So that computer has two channels to control that system. Okay, And then you also have your probes. The probes are installed in each of the fuel tanks, okay, because they've got to monitor, and then they got to send that information, that data, to the computers through the channels. And that's how that works. The probes are actually split up, okay, as far as categorized into an A and B group, and that data is just sent over through one of the channels to the computers. Okay, so you have probes in the tanks. So if you ever have that opportunity, you're going to see those probes, there. And then also you have the capacitance index compensator. That's part of the lower probes in each wing, inner cell, and also in the center tank. So you'll find that there as well in that area. The condensicons, those are installed near the lowest part of each fuel tank. Okay, because that's going to be measuring or calculating the fuel density. There's different properties to fuel, and if you're interested, you can, we want to have more things here to offer you as far as just information about things like that, because it gives you kind of an expanded view of your own job as a maintenance technician when you're working on this type of stuff. Okay, so at any rate, fuel density. So that's what the condensicons are doing, is they're installed near the lowest part of each fuel tank, and they're just regularly monitoring. So it's like on a time schedule to monitor the components, and all that is used to calculate that fuel density. Okay, and we could go into a lot of physics here. Don't want to inundate you too much unless you want to get inundated with the stuff, but there's a lot they're talking about mass temperature, and when I say mass temperature, I'm talking mass/temperature. That's like foot-pounds, or when we talk about energy in foot-pounds. It's just it's a unit of measure, as we have mass related to temperature. And so when you look at fuel density, which what these components do is they're monitoring that, because the fuel density is related to the fuel mass. Okay, and you have fuel mass, we're going to relate that to temperature. So it's all, there's a reason why we have these particular components that are measuring these types of properties. All right. There's also, you're going to find there's some plug connectors in the wiring, and those are going to be located in each of the wing tanks. Okay, and there's different kinds. You've got your shorting plugs and your fuse plug, or your shorting plug connectors and your fuse plug connectors. So those are at the wings. Your fuse plug connectors in the wiring, those are contained in each of the wings and also in the center tank. Okay, so that's for the fuse plug. The shorting plug, is found, only in the wing tanks. Okay, and just kind of a heads up, this is another kind of part, and I'm referring to the wiring for the fuel quantity system and indicating system, where it's listed, specifically defined as one of these critical design parts. So, just heads up right now. Put it in your notebook, write it in your notes. That way when you get to the AMM and you're looking also, because you have all these other, as all the other publications for maintenance, make sure you pay attention to the critical design configuration manual, etc. Okay. All right, so just kind of a reiteration here, when we talk about the fuel quantity indicating system, what components do we have? What makes up that system? Okay, well, you're going to have a multi-tank indicator, you're going to have pre-selector, your condensicons, you're going to have your, I didn't mention this, but you have your onboard replacement or replaceable module. Okay, so that's your ABRM, onboard replaceable module, your computer for this system. And of course, remember I mentioned the probes that are located in the tanks. Okay. All right, so what kind of displays can you have with the fuel quantity? What can you expect on these things? Okay, well, you're going to be, remember I mentioned that you're using fuel density to figure out the fuel mass. Okay, so that's going to be one that's going to show up on the ECAM. You see what I mean? So there's a reason why those probes are there. That information is going to be, showing up. So the fuel mass is shown on the ECAM as well, okay, with the ECAM and the SD fuel page. Okay, now if there's any condition where, or I should say the circumstance where there's a refueling or defueling going on, then the multi-tank indicator is going to show the quantity of fuel in each of the fuel tanks. Okay, and then it'll have the word actual on the pre-selector. Okay. As far as accuracy on the indication system, it's accurate plus or minus 1% of the maximum tank capacity. Okay, and also 1 or minus 1% of the actual FOB. Okay, fuel on board. Okay, and that's when the aircraft's on the ground between a certain pitch and roll. Remember, because you have different attitudes of the plane, it's going to vary. So you don't have to memorize this stuff, but I'm just sharing with you the concept that that's just a reality. It's going to be different. And so as far as your total capacity, and those, it's going to be different on the quantity indication. Okay, now as far as your indications, the fuel quantity indications for center tank and both wings, okay, inner and outer cells, are accuracy below 3%, double amber dashes. Okay, so that's going to be double amber dashes on the last 2 digits. Also going to be showing fuel temperature in Celsius. That's normally green. There's a pulse green, and then it changes to amber if there's a problem. So if it's gone outside its range. Okay, and you can get an idea with the diagram and the picture of what that looks like when you go to our the pictures section. Okay, so those are what you expect on displays. Now a little bit more on the computer for this quantity indicating system. And so with this computer, you've got basically your components are going to be your CPU board. It's a computer. So you got acquisition board, your power supply assembly. I mean, that's you have to have that. It's 2 channels. Remember I said earlier. So you got 2 channels. They're exactly the same, channel 1, channel 2. And they each have an acquisition board, also a CPU board. So each of those channels are identical, like I said before. So what's the purpose of these 2 channels, on this computer? The channels are going to be actually testing for faults, right? And they're also going to be sending out discrete outputs to the refuel valves and also the flight warning system. It's going to be also looking for, again, any system failures. Okay, it's going to be computing the fuel mass that's held in each of the wing tanks and also the center tank. So that's remember I mentioned about the fuel mass and density. All that. Well, the probes have to do with the fuel density, which leads to being able to calculate the fuel mass. So this computer is computing the actual total fuel mass and also the pre-selected fuel mass. Okay, and like all the avionics stuff, this computer is located in the forward electronics rack. Okay, so just follow where exactly, but I'm not going to mention that. But it's in the forward electronics rack. You also have an onboard replaceable memory. That's what the OBRM is. You've got just a connector plug that attaches to it and goes to the computer. Okay. I have to say, electronics has come a long way as far as, it's been around for a long time, but improvements have been made to obviously protect it, because that's kind of the brains of the operation for all these different systems. So, you know, again, you've seen these, they just have good cases around them, etc. Okay, so that's what I have to say on the computer. There's really not much else for me to say about that. So let me go ahead and move on to the probes, because remember I said the probes, you know, are there in the tanks and around. So with the probes, okay, this just, you know, I can't stress how there's all these different parts pertaining to the fuel system that are pretty critical. So that you don't have with other systems, and we'll talk about hydraulics, etc. Again, because of the nature of, you know, the potential here. All right, so with the probes, there's the single probes. These probes can have failure. Obviously, they can fail, and so sometimes if they fail, it's not going to be the end of the world. I mean, it's not going to cause everything to come to a halt. Some of the ones that do fail, you're able to continue, you know, the system can continue successfully, just depending. So, because these particular ones are class 3 failures. Now, you have certain probe numbers where that's not the case. That if they fail, there is going to be a big problem. And so, we'll just probably mention this in the forum. Again, I don't want to mention the probe numbers because I'd rather you know that at least there's some probes, at least 3 or 4, that are critical to the operation, okay, that's running, and the rest of them, it's not so critical, okay. So these particular ones, if they do fail, you know, there could be some problems. In some cases, there's no impact on the quantity indications, so that one kind of stays intact, so that there's, you know, that the pilot can know how much fuel there is. But as far as the temperature of that fuel, that can be lost altogether if you have a failure of the critical probes. Okay, so you've got that. All right, so probes, mounting brackets that you have, the probes have the mounting brackets, and they're going to be in the lower and also at the sleeve at their upper end. Is how they're usually mounted. Pay attention to the brackets. Just look for, if you're happening to be working on this stuff. Remember, I just said heightened awareness. If you see any cracks, this is what happened with an APU that was had couple of broken mounts to it, and it dislodged the APU while the plane was in flight. So I'm just saying, you know, how critical is this? You know, treat everything as critical, right? So here, just pay attention to the mounts, make sure they're not damaged, there's not fractures on them, because that, you know, is under tension. And if you have a weakness, obviously, in that, you know, steel and that metal, you know, that can cause problems down the line. Okay. And the other things that I mentioned besides the fuel probes is also the condensicons. So these condensicons they're like a little computer too, but you know, again, they're probing, so they have to detect. That's its job, is to detect. So it does have a detector assembly. You've got a base assembly. It does have a circuit card in there, and of course the cover. So all of that are on the base assembly, and the base assembly has connectors. There's 7 of them, and then those connectors connect to the condensicon to the related harness in the fuel tank. So it's all, you know, it's obviously all connected. The fuel moves freely into and out of the condensicon through the holes in the cover. So that's a normal thing going on there. The dielectric, you know, property that we have with fuel is happening between parallel plates of the capacitor assembly. I'm getting into electricity right now, but you know, that's just a reality. Some of you are avionics technicians. It's not the Greek that I'm talking right now, but that's just the nature of that, or the nature of the property of that between the parallel plates on that capacitor assembly when that fuel, you know, goes in and out of those holes and through the cover. Okay. The actual detectors assembly, those have circuits as well. It has also a weight and a float in it. And those are all connected to an axle assembly. in the way it's, put together. When you're replacing these things, you're not, you're actually not taking these things apart, but you're just replacing the entire assembly. Okay, so that's, that's what you have with that. And again, this is a critical design configuration item, so, just know that's the case. The shorting and fuse plug connectors, like I mentioned before, remember I said how you have those in the wings and then wing and center tank for the fuse plug connectors. Okay, well, so here's what you have. You had them on the wire, installed between the external wiring harness and also the in-tank wiring harness. Okay, so that's where those connectors are located. And those are all behind the access panel, and I'll just let you follow your AMM as far as location exactly, but anyway, those are where they're located. Okay, and those connectors are just connecting what? External to in-tank wiring. So it's connecting those two wiring harnesses. Okay. Now, be aware that the you can't. There's no interchanging here with the connectors for the shorting plug and the fuse plug. They are different. So you can't interchange or use those connectors interchangeably. Okay, so of course with the fuse plug, if you're familiar with when we talk about circuit breakers and just ways to protect the circuit from shorting out and having a risk of fire or whatever, fuses are used. Okay, because if it's going to hit, it's just like with those static dischargers, right, at the exterior of the aircraft. If it's going to be a lightning strike, rather hit those things and ground itself there. But the fuses kind of do the same thing. If there's some kind of a short in the circuit, the fuses are going to be the ones to be hit and, of course, blow out, which is completely fine. That's what they're there for. So the fuses are used there to prevent the short circuits between your quantity indicating system, the cables there, and your electrical supply. Okay, so that's just all decreasing that risk of any kind of problem with too much heat, which can lead to, some other problems. So temperature too high in that area. All right, so it gives you an idea with the connectors that we have. So if there were a test question, what are the two test connectors? Okay, you got your shorting plug connector and your fuse plug connectors. You also have a magnetic indicating. This is on ground only. When the plane is on the ground, there's a magnetic level indicating mechanism there, and it's just pretty mechanical, but it's magnetic. But it's measuring the fuel. Okay, for all of the tanks. And because it runs on magnetic, you're not having to run electrical power to it. You're just, using the mechanism there with the magnetism. So what you've got 5 wing tank MMIs. Okay, so you got those magnetic indicators located at the bottom surface of the wing tanks. And the center tank MMI, okay, that one is in the belly fairing. And that's directly below the center tank. All right, for the measurement of that fuel for quantity. All right, so again, just pretty simple with reading. It's just going to be, as far as the reading, it's going to give it out of level attitude of the aircraft and the pitch and roll axes. Because remember I said attitude can obviously change the indication for that fuel quantity. Okay, so part of our measuring here, let's talk about the tank fuel level sensing. Sensing whether there's a high level or a low level sensing for the center tank fuel pump control. You also have an overflow level sensing and temperature. Okay, so you get temperature. And then also the wing tank intercell fuel transfer control. So you have fuel level sensing system giving these different indications. You do have fuel level sensing control units. Those are going to be monitoring continuously. So you got that going on. There's 2 sensors, and then there's 3 under full level sensors. So you have 2 full level sensors, and then there's 3 sensors for if it's under full, and under the under full level. There's also your overflow sensors, located 1 in each wing surge tank. And then of course you have the IDG. I didn't mention earlier about, well, I have, but the integrated drive generators. You've got shutoff sensors that are located 1 in each wing tank. So, so basically if you have one of those sensors become dry, okay, because these are in there in the tank, if it becomes dry, then the control unit's going to send a signal to the FADEC to close it, okay, and then stop the recirculation system essentially. You also have 2 temperature sensors as well. So it just gives you an idea of the different sensors that you have going on with this entire fuel system. Okay, just kind of a little bit on the control units. For the fuel level sensing, you've got the 2 control units. Those are powered by 28 volt DC. Basically, it's there to detect, it has a detection circuit to find the thermistor, basically to find when a thermistor is in the fuel. Okay, that's just one thing. It's just fault monitoring. All right. Okay, so we talked about the MMI, which is your manual magnetic indicating, happens on the ground. And then just the fuel quantity indicating system and the computer involved with that, and the different kinds of probes that you have with all of that, as well as your condensicons. Okay, and now let's I want to address the vent system. Okay, that was the quantity indicating system, and now I want to look at the vent system, because remember I said about how there's got to be a, kind of a way for it to be exposed to atmospheric, the air. So what we're going to look at here is these vent tanks, which we have, and we want to have this. We want to have an equalization, if you will, of pressure that's constantly going on, because you don't want to have a buildup of pressure inside the tanks. That's definitely not what we want. We want to have it balanced just as we need to have it. So you have tank venting systems, and that's going to just let it's monitoring it, so it's going to let out X amount of air in or even out, so into the fuel tank or out of the fuel tank, whatever's required at that particular point in time. Okay, so those vent tanks are important. Okay, so the tank venting system, what comprises the entire venting system? Okay, your venting system is going to have or involve your overpressure protectors. You have also your overpressure protectors and your vent protector. You have your valves. We're talking about your check valves and float valves. Okay, that's what makes it up. Now, there's a vent system for each tank. Okay, each tank gets its own vent system. So it has vent pipes. Each one has a vent pipe, okay, that's connected to its corresponding vent surge tank. And those things are connected by a duct. Okay, those are your stringer vent ducts. Now, your overpressure protectors, those are installed because if there's too much pressure being, it's already been built up in those tanks, then it's going to need to release some of that pressure or relieve it. And so you've got these protectors, and essentially it's just a disc. It's kind of like when we talked about oxygen. If you've ever been in those classes, there's a disc like on the actual, component where, you don't want it to give it a chance of overpressure. It's going to actually break the disc. So the disc that breaks is contained, that is associated with this, is contained in a basket, okay, in the valve. And so if there's an excess pressure in an outer cell, if there's pressure there, it's going to relieve into the inner cell, but it's going to do it through that overpressure protector. Okay, so remember, overpressure protector is going to relieve it's going to be a relief. So the two wing fuel tanks have the outer inner. So outer cell too much pressure is going to release some of that into the inner cell. If it's the center tank, center tanks, then what that protector is going to do is relieve that overpressure to the left-hand inner cell. Okay, and that's all going overboard. And again, vent systems are very critical. Can be very hazardous, so please be careful. Okay, so the vent surge tanks themselves, let's just go a little bit deeper with the components pertaining to the vent surge tank. Okay, so the surge tank is open to the air through a duct, and that's going to be on the access panel. And you have a front vent protector there, and that's installed there. So basically, you're trying to prevent any ignition from happening. Also, there's an ice protector because you don't want ice to form there either. All right. Okay. And just kind of be aware of with the vent surge tank and these safety discs, okay, that I mentioned. Those safety discs for the inner cells, those have a white cross painted on them. So if you can see the cross, the disc is not broken. Okay, but if this is broken, obviously it breaks that up, so you can't see the cross. So just to be aware of that. If you're going to be installing any vent components, again, be aware these are on a list. There's a certain configuration that they're considered critical components. So, you know, again, be very, very careful that you pay attention to exactly what the AMM states for that, because there's a deactivation, reactivation of the overpressure protector. And that has two different jobs, if you will. So make sure you're talking about the same one. Make sure you're addressing the right one. Okay, so those are your wing tanks. I'm talking about the vent surge tanks there. Now, with the center tank, it's an external venting system here that we have the fuel or the fuel gas that comes out of the center tank. That is actually externally vented to make sure that it doesn't go into the aircraft structure. Just by the nature of where this is located, it's there. And so you could have, you're talking about fuel vapor, right? So all that can be ventilated. And that whole system has a seal in there so that it seals the bottom of the tank and protects it from not seeping into the air conditioning compartment, because it's right below that, or the air conditioning compartment's below that. So it has to be sealed completely, because that does not you don't want to have fuel vapors going into the air conditioning compartment. Okay, so you got pressurized air in that air conditioning system, and that flows through the space between the vapor seal and the center tank. So continuous flow of that air, okay, is just caused by differential air pressure. Now that seal, the seal itself, obviously look for anything that doesn't look right, like just maybe the wear and tear of it. But that should, I won't go into detail on what it is, but just kind of do a visual check and make sure it looks good. If there's something out of the ordinary or just kind of a hunch that something's not right, certainly you want to address that. There's also a leak monitor, because we want to have a fuel leak. So you do have a monitor there. It's just a pipe that connects to the drain line, and there's a check valve there installed at the end of the pipe. Okay, so basically the check valve is allowing you to take a sample of the drainage. Okay, so is there any fuel leakage at all, you can take the sample, and you have that ability to do that with that. There's a drain mast also, your operation of course control indicating. With the operation of the wing center tank, or the center tank external ventilating system, that is actually fully automated. There's no control of that system. Okay, and just anything in the center about the center tank as far as the ventilation system goes, there's nothing that's going to show up on a display, is what I'm trying to say. All right. So that's your vent surge tank and the components there. There aren't that many, but these are critical components. So just kind of keep that in mind. Okay, so what about the intercell? Remember I said there's an outer cell and an inner cell. So with the intercell, okay, what does that mean? This is an intercell, so we're talking between two cells. Okay, so in order for us to just help with the integrity, okay, of the entire aircraft, we got to look at structural loads as it pertains to, to fuel. And so there's going to be this gravity feed that's going on through a pair of transfer valves. Those transfer valves, and this is happening only after fuel is used to a certain level. Okay, so basically it's only after it gets kind of low in the inner cell of that fuel tank. All right, so you can do a test of this entire intercell transfer system through the MCDU. Okay, and with the transfer valves, the intercell transfer valves are on the outboard side of a particular rib number, with this actuator on the front face of the wing, so wing's front spar. So that just where you know where it's located, and kind of what these are there for. Of course, you've got actuators on each wing, and those are powered with your basic 28 volt DC, and one's coming from one bus bar, and the other one's coming from the battery bus bar. Okay, your bus bar 2, and then your battery bus bar. Okay, so of course you got backup there if one fails, so that's what's happening there. Okay, so when we look at this intercell transfer system and the function, it's going to be looking for, remember I mentioned about the sensors. Okay, the sensors, one of the sensors job is it's going to sense low level. Okay, so there's 2 sensors for that. So when that becomes dry, it's going to send a signal. Remember I said that before. It's going to send a signal to the left and right hand intercell actuators, because this information ends up going to the computer, so it can be displayed. But so when that happens, and just so you know, the intercell transfer system is controlled automatically, by the computer. So like I said, if it reaches a certain low level, the valves are going to open. Okay, and they're just going to continue to stay open until there's a next time that the planes get refueled. Okay, so that's what you have with those intercell transfer valves. Okay, and you also, you have indication for this. This is going to be your ECAM SD fuel page. It's going to show a warning there. Of course, remember I said green is good. Well, green is in a condition of, then for this particular case, is going to be green. The vertical lines is going to be meaning that the valves are closed. Okay, those intercell transfer valves are closed. Okay. Now, if you have the 2 transfer valves in the wing tanks fail, so they're supposed to open but they don't. Okay, then what's going to happen? Okay, what's going to happen on the display? You're going to have an indication of amber, the amber color for the fuel and quantity indication, and you're also going to have the fuel quantity indication that's going to show. It's going to show in a boxed form on the display. Also, your fuel on board, your FOB, on that page is shown in amber, and it's also boxed. There's going to be a box around it. Okay, so that gives you plenty of indication when you have a failure of those transfer valves. Okay, so what about the let's look at the main pumps. Remember I said that there's a pump for each of the fuel tanks, And I was also telling you how the center tank doesn't, if its pump goes out, you know, that's just it. There's no backup system for it to distribute fuel to the engines. Whereas with the wing tanks, you know, you do have that ability. It goes into a suction feed essentially. The engines are going to make sure it gets that fuel from that source. So let's look at the main pumps here and just talk about a little bit about the pumps that you know, go along with each of the tanks. The pumps are your 3-phase typical 115 volt AC motors, and they're actually installed in a canister. So if you see the word canister in AMM, that's why, because they're encased, they're installed in a canister. And so you have the pressure that's going to be limited by sequence valves. It's going to allow center pump priority first. So sequence means in a certain sequence, certain priority order. Your wing pump canisters, okay, so you've got your fuel pump element that's located in the canister. That's actually attached to the wing bottom skin. And then you have, that canister has 3 outlets to it. You've got a vent valve, your outlet that's connected to a sequence valve. And then you have an upper outlet that's connected to the engine feed line. Okay, because remember what I said, it'll suck it. It wants to, if for some reason it's not getting fuel elsewhere, you know, and it gets just a backup, then and the pump is not able to get that fuel to the engines, at least there's a feed line so the engine can get that fuel. Okay, and as far as the physical location of the element, remember I said it's located in the canister, but that's attached to the center tank bottom skin. Okay, the center pumps. Center pumps are similar to the canisters for the wing fuel pumps, but remember the difference is it's not going to have that suction valve, because remember I said that there's, once that pump goes out, there is no suction line or feed line for the engines to get that fuel out of there. Okay, if you're going to be removing any pumps, okay, let's just say for the wing pumps to start. The wing pumps are located between ribs 1 and 2 under a cover plate and a fairing assembly, so you're going to have to remove those in order to get the access to the pumps, right? And then the center pumps, they don't have a cover plate, but you can get to them through the hydraulic bay panels. So 2 different locations or access panels for, you know, accessing the center pumps versus accessing the wing pumps. Okay, now the whole idea with having a canister, because, you know, why even bother? I mean, why not just keep the pump there and install the pump and not worry about it being installed inside or you know, in a canister? Well, the reason why is because you're able to actually replace it without having to drain the entire fuel tank. Okay, I mean, so that's kind of nice, right? If you have a separation of that and you can just replace the pump. So that's what that is. And there, you know, I know there's you know, aircraft specialty tools, but just so you know, here there's a specialty tool for removing the pump, you know, the fuel pump. So, you know, just follow the AMM, follow your list as far as what's required insofar as tools are concerned. Okay. There's a slide valve on the canister itself. So, you know, when that actually closes in order to seal the fuel entrance to the canister. So it's you know, essentially, again, like I said, you don't have to be, you know, draining the entire fuel tank in order to get that pump out. Okay, there's also a drain plug. That's just to drain a small amount of fuel that might be trapped in the canister. And just, you know, make sure the slide valve is blocking the fuel. Obviously, you want to do that before you start removing the pump. Might sound simple, but, you know, I should say a lot, but some maintenance people have forgotten to turn on the electrical power, for example. Make sure there was electricity going, so electrical power. Here, just make sure that, you know, double check that slide valve is there blocked, so that fuel is not coming, not available there when you're removing the pump. There's a retaining pin and a spring assembly that's going to hold that slide valve so that it doesn't, does not get removed from the pump and accidentally causes a fuel leak. So those stop pins, or the retaining pin and the spring assembly, are important to make sure they're, installed properly and just working properly. Okay. All right. And I'm sure that it's happened. That's why I stress. But I'm sure there's an aircraft mechanic out there somewhere who didn't follow procedure and, fuel's a mess. I mean, it smells for one, but it's a hazard. You don't want to have fuel all over you. So, be careful. Make sure you do spend the time at a little extra time if you're used to working pretty quickly, because you have to, but in many cases. But in this particular area of the aircraft, just take a little bit extra time and be very methodical with this, because fuel is a hazard. Okay, not just to your skin, the body, the clothes, but obviously you're dealing with something that's flammable, so be very careful. Okay. Now, it's important about temperature. Temperature is a danger in one direction or the other, but most importantly, I would say more importantly, if it's too high. So if you have too high of a temperature of the pump element, okay, if that gets too hot, there's a mechanism in it that's going to stop. It's going to stop that pump element, basically, because it doesn't want to. You don't want to have it overheat. So if that goes more than 347 degrees Fahrenheit, then there's thermal switches that are going to cause that pump element to stop. Okay, now once it's stopped, that's it. I mean, that's the sign that it's time to just do some replacement. It's not going to operate again. Now, remember I said about the suction valves? You do have suction valves with the wing tank fuel pump. The suction valves, those have a controlled fuel leak rate when it's in the closed position. Okay, so I just got to be aware where the suction valves are involved, and then they're not involved with the center tank fuel pump system. Okay, so your air release valves, your sequence valves that I mentioned earlier, these are located in the wing pump canisters only. We can talk about the sequence valve. The sequence valve is located on the wing pump canisters only. So, I said it. Sounds like a test question. So, just be aware of that. Your sequence valves, I'm going to go into the detail of the components. I mean, you've got your standard spring poppet valve, your valve body, etc. You also have your air release valve. The air release valve, similar components, although here you've got your vent valve assembly and a diaphragm with it. Your release valve has a mounting flange at the bottom, and then there's a check valve at the top. Okay, so you know what that's like. And then you've got in the stable or suction condition. Okay, when let's say that's being operated because the pump didn't work, that check valve is going to close. It's going to close because it's going to seal the valve. When the pressure in the valve is equal to the pressure, in the fuel tank. Okay, and then here's the thing. There's also the air and fuel condition. So when you have that condition, if air goes into the float chamber, there's a float chamber, okay, which contains an annular float, and this is part of the air release valve, by the way. So say you have an air and fuel condition. You got air in the fuel. That air is going to go into the float chamber, and so if it does, and the float's going to fall, and that's going to open the diaphragm chamber. Okay, and so when you have that whole thing operating, the air is going to become pressurized, which is going to cause this whole chain of events, right? You're going to have that diaphragm valve assembly move to open position. You're going to have the check valve open, etc. Okay, the other condition you have besides air and fuel, you also have bleed of air condition. So when the fuel goes into the float chamber, it's going to lift it, and that's how it seals the opening of the diaphragm chamber. Okay, and then you have the check valve that's going to close to seal the valve. So those are your sequence valves, your air release valves, just mentioned right now, your air and fuel valve. You've got pressure switches, and you also have jet pumps. Okay, so where are these things? Your jet, you've got a jet pump, and that jet pump body's located it's actually the jet pump body has a flange, and it's at one end of it's basically for installation to the tank rear part spar. That's where it would be installed. You have the wing jet pumps. Okay, those are located obviously on the wings, but that's going to be at the rear spar. So whether it's in the tank rear spar, or you got the wing rear spar, those are where those jet pumps are located. And then as far as your pressure switches, the pressure switches for the fuel pumps, those are located on the rear face of the wing. And like I just said, for rear face, or also in the tank rear spar, those pressure switches are there. And so basically, when you need to be aware, or not you, but just like it has to be, a certain pressure. The main pump, if for some reason it has to maintain a certain pressure, PSI. If for some reason it drops less than 6, then that's when the pressure switch is going to, switch on, and that's going to put an amber fault light on the panel. So that's going to show up on the main pump push button switch, and that's going to send a control signal to the control unit for the fuel level sensing, and of course that all shows up on the ECAM, right? So that's kind of your threshold there is 6 psi. If it drops less than 6 psi of pressure on the fuel pump, the amber lights will come on. All right, so you got your LP fuel valve. That's your low pressure fuel valve. That each of those valves isolates the engine, okay, from the fuel supply at the front spar. Okay, so there's a switch for it's the ENG master switch, or engine master switch. Then that one is actually controlling that low pressure fuel valve. All right. Okay. Okay, a little bit more on this shut-off valve. You've got a couple of motors involved. I mean, it has a ball valve design, okay, in it. But as far as the fuel valve and its actuator, there's actually, the actuator has 2 motors to it. It's 2 electrical motors, by the way. And that's going to be moving the gears to turn the ball valve. Okay, so remember I said there's a ball valve in there. How does it get moved? Well, there's the actuator that has 2 motors, and that's going to be driving a gear, your differential gear, that's going to turn that valve. Okay, you've got limit switches also in the actuator control as part of all that design. Okay, all right. So it hopes it gives you an idea on that. Okay, on the low pressure fuel valve. Excuse me. All right, so let's kind of move on a little bit to the crossfeed valve. And then we'll talk a little bit on the distribution after we get into a little bit more on the. I'll just kind of touch on the APU bleed system, your APU fuel pump. Not a big thing, but let me just cover crossfeed valve, and then we'll kind of eventually move over to the fuel recirculation. Well, the crossfeed valve, remember what I said? What's its job? You can either isolate or not isolate, right? So your crossfeed valve usually is closed because it's dividing the main fuel pump system into the 2 parts, right? One for each engine. Makes sense. So, but if it's open, then it's going to allow fuel supply from, either side, and it can be connected. Okay, so where's this crossfeed valve located? Crossfeed valve is installed on the forward face of the center tank rear spar. Okay, and crossfeed valve, you got your spindle, your drive assembly, etc. Okay, just know you've got the crossfeed valve that's located, as far as the location, it's on the forward face of the center tank rear spar. Just like a lot of these valves, they have actuators. Okay, so this one's no different. Got that as well. Okay, so you have an indicator on here. It's a switch indicator lights. Those are going to show on in white when the switch is pressed in. And if the switch is open, then the color is going to be green. Okay, that's assuming that the crossfeed is fully open. All right. Okay, so let's kind of go over some a little bit about the fuel pump indication. Excuse me. Because we want to make sure that the fuel pumps are working, right? So if there's a failure, we want to know about it. Those things are going to show up, obviously, on the FWC. You're going to have auditory warnings, and besides visual on the screen, you're also going to have the chime sound. So with here on the ECAM, it's going to show the failures on the EWD and the fuel page. Okay. And then if it's necessary, if there's a way to correct some of this stuff, you're going to have a procedure for correcting that. It's going to have that on there. What's going to show is indications for your center tank pump, obviously your right tanks, your fuel, like I said, the fuel center tank pumps. Okay, whether it's low pressure or they're just, if they're set to off. So fuel center tank pumps off. That just means the center tank pumps are set to the off position, and they're fine. There's no problem with them. But if you have a low pressure situation and the pump's on, you're going to have an indication on that ECAM. Makes sense, right? Okay. Obviously, the word fault's going to show up in amber if there's truly a fault going on. Okay, so that's kind of your indications that you have. Your main pump operation, you've got mode select. Okay, your mode selector switch, because remember you have two choices. It can be main pump operation can be in manual or in auto mode. So automatic, pushed in, pumps are switched on, so the pumps are operating automatically, so that they're operating as necessary, as demanded in any particular point in time, in different phases of flight, right? Now, if it's in the manual mode, or you have the refuel door that's open, then the pumps are selected on or off by operating the pump switches, because you're manually doing it, right? Okay. And then also, there's when we have the electrical smoke configuration, when we're in that condition, you've got the left or right, okay, either one. Tank pump 1, push button, then that's going to connect to the electrical supply, to the number 1 fuel pump. Emergency contactor control. So that it's making, so just to let you know how that's connected there, and that's in that condition of electrical smoke configuration. Okay. All right. So, let's kind of just let me go ahead and kind of move on to the recirculation and cooling of fuel and distribution a little bit, and then I'll get into the APU probably after that, or if not, we'll just kind of go over a refueling and defuel system, because that's another system we need to cover. But let's just kind of go over the recirculation and the distribution of fuel. So what do we have here, that we need to kind of be mindful of when it comes to the refueling? When we talk about the recirculation, excuse me, because we're cooling, because remember this is involving the IDG, and what it's doing is the IDG oil in particular that I'm talking about. It's that fuel is actually used to cool the oil of the IDGs. Okay. So how does this work? Okay, well, you're going to have, fuel that's kind of hot. It's actually, warm fuel. It's from the IDG cooling system that's returned and is mixed with the outer cell fuel. So it's part of the oil cooling system. Okay, and that's part of the fuel supply to each engine, and it's helping to cool that oil in the IDG. Okay, there's also a return valve. The FRV, or fuel return valve, is going to control the flow of fuel back to the outer cell tank, right? So recirculation, that's what I mean by recirculation, and the cooling that's going on when you recirculate a liquid, a fluid. Here in particular, we're talking about the fuel. So circulation pipe is involved. You've got check valve. You also have a pressure holding valve. Okay, so with the pipe in particular, the pipe, okay, that one is, you have, that one's going to be located between the return valve and the holding valve. Okay, and that's going to be on the outboard face of a particular rib number in the wing tank. Okay, there's 2 holes, one on each side of that rib, and that just lets the warm fuel go into the wing tank outer cell. Okay, with recirculations, you also have the check valve. Okay, and that's actually on the lower surface of the wing bottom skin in the engine pylon. And so with the recirculation pipe, with the check valve, you've got this connection between the recirculation pipe from the engine and that going to the recirculation pipe in the wing. Okay. Now, what about the holding valve? Okay, this is a pressure holding valve. That one's located on an adapter that attaches to the outboard face of a particular rib number. Okay, just follow the AMM exactly where it's located as far as the rib number, but just so you know, it attaches to the outboard face of that, of a rib. So what happens is when this is in operation, okay, when you have that recirculation going on, what is the pressure holding valve doing? Okay, it's going to keep a pressure. Holding means it's like it's holding a particular, level of what, in this case, it's talking about pressure. So it's going to keep a pressure of 15.5 psi in that recirculation pipe. So as it's going through that recirculation process, the holding valve is basically almost like a regulator. It wants to keep it at 15.5 psi. Now, of course, if it gets to beyond that, then the valve's going to open, because they want to relieve some of that pressure so it can go down to get to the 15.5 psi. Okay, because we want to have a certain temperature. Fuel temperature is important, so we don't want to have too hot of a fuel that's running through the recirculation pipes. Okay. All right, and of course, all of this is like your fuel return valve that interfaces that's part of the recirculation system is interfaced with the FADEC. Okay, so with your FADEC, that's the one that's controlling this valve to stop or not stop, just regulating it. It's controlling it. Okay, and there's diagrams giving an idea of the rib numbers. I'd rather just have you follow the AMM at your MRO where you work, but this is just for illustration purposes only. This is definitely superseded by the AMM. Okay, so when you see this, just keep that in mind. Okay, now distribution of fuel. That was recirculation for the cooling of the oil for the IDGs. We use recirculation pipes. We have the pressure holding valve so that we don't have too much pressure in the recirculation pipes. And now we're talking about distribution, because we want to get that fuel to the engines, right? So the fuel distribution system has different parts to it. We need supply of fuel to the engines. We also need supply of fuel to the APU, and also the refuel defuel system, which we'll get into in just a little bit. Okay, so with here, you got fuel supply to the engines we got the boost pumps. We got 6 boost pumps that are located, one for each tank, right? So if we have a failure of one of the tank pumps, if we have that, then we have the other pump that's automatically supplying the fuel. Okay, so we don't have a problem with when it comes to that. Now there's a collector cell. That one is located between 2 ribs, and also the front and rear spars and top and bottom skins. You're going to have the collector cells. You have that, and there's also clack valves. Okay, those are in the bottom of a certain rib number. Your sequence valve I mentioned before. Those are on each wing pumps canister. Okay. Basically, it's deciding or monitoring and making sure that you have center tank fuel to be used first. Okay, so if you have the center tank that's empty, fuel then is going to be used from the inner cells. Okay, so I kind of went over a lot of as far as the distribution of the fuel regarding coming from the center tank or coming from wing tank, because the wing tanks have suction valves. So that's going to happen in the event that the pumps are failing. All right, so that gives you an idea with the main pump operation, etc., and kind of the distribution that we have with that. So let's look at the refuel defuel system, since I just mentioned it. Okay, so with the refuel defuel system, okay, what are we referring to here? We've got the control of the fueling, the defueling, or any ground transferring of fuel. And we're going to be doing it through the control panel. There's the control panel for the refuel, defuel. There's two different procedures that you can possibly be exposed to when it comes to refueling the aircraft. Just like with other things, I mean, we got gravity fed, right? So, gravity refueling or pressure refueling. Just that's the fact. I mean, that's the case. Those are the two kinds. So you fill the fuel tanks to their maximum capacity. The aircraft has to be level. There's automatic refueling, and that would be controlled by the fuel quantity indicating computer, your FQIC. So as far as your components with the refuel defuel system, there's a list. Okay, we're not expecting you to memorize all of this. I'm just simply sharing this with you on a GenFam, and then also on these slides you might just kind of visually do a spot check. Okay, here are some of the components that are involved with the refuel defuel system. Obviously your spill pipes. You've got spill pipes, your transfer valve, that's your defuel transfer valve. You have 5 refuel diffusers, 3 refuel valves, obviously the control panel, okay, and your coupling caps. You got 2 air inlet valves, the pressure relief valve. Okay, so different valves that you have going on here in this system. All the refuel process is controlled from the refuel panel. Okay, so basically you're going to open the control panel. It's just a quick release door, and then when that's released, when that's opened, then it's going to send a signal to the computer. Okay, that's going to connect to electrical power, and then eventually to the electrical circuits for the refuel defuel system. Okay, now refuel pressure at the couplings, because it depends on what you're talking about, right? At what point in the system does there need to be a certain PSI? Earlier we talked about the pipes earlier, the recirculation pipes, and how we have to make sure they maintain pressure holding valve, right? It's going to make sure it's at 15.5 psi. If it's not, if it gets too high or past that, it's got to release some of that to bring that down to 15.5 psi. Here we're talking at the pressure at the couplings, so it's specific. So pressure at the couplings are at 50 psi. So as far as operation goes with refuel defuel system, at what pressure does it need to be at the couplings? It's 50 psi. Okay, because when we have that, then we have an average flow rate that we can determine that we want in order to fill the tanks from empty to to capacity within a certain time frame. So that is why, because we want a flow rate, right? Well, how many gallons per minute can we get? So we have to have a certain pressure to yield that. So with here, flow rate, roughly about 97 gallons a minute. That will fill tanks that go from empty and fill them up, and it does it in 23 minutes. So you want to hurry up and fill up the gas tanks the fuel tanks, if you will. That's how that's done, is that pressure has to be just right. Okay, so during the auto fueling, okay, so we're just auto fueling with the refuel valve switches that are in normal position. The mode select is on refuel. Then those valves are going to open and the tanks are going to start to fill. Okay. So what you're going to have is the inner cells have filled to the low level. Okay, when that happens, then the transfer valves are going to close, because it's at that level for the inner cells, and it's going to allow the outer cells now to fill. Okay, so that's what that transfer valve does. It closes the inner in order to allow fuel to be in the outer cell. And of course, you have your pre-selected values for the fuel. Reaching that certain level, obviously the valves are going to close. Okay. All right. So a little bit on the fuel defuel control panel, and then we'll kind of talk about the coupling and cap for a little bit, and then we'll kind of move on to a little bit more in the canisters. Okay. So with the aircraft, it's normally pressure refueled. Okay, and it's done with the control panel, like I mentioned earlier. The control panel, where is that located? Okay, the refuel defuel control panel is located where? Okay, that's going to be in your right wing axis. Okay, the fuel is automatically distributed into the tanks by that selected quantity. So it's from the pre-selected quantity. All right. You also remember I said before you had a multi-tank indicator. So if you're refueling the aircraft, you've got a multi-tank indicator, your refuel valve selector. Okay, so that's what I mentioned earlier. And then your high-level lights. So there's a blue high-level light for each tank that comes on. When the associated high-level sensor is wet, then there's going to be a blue light coming on. Okay. And once that happens, once it's wet, then the refuel valve is going to close. You also have another kind of, I should say another type of switch. You got a rocker switch. But basically, if you trip the rocker switch to DEC, okay, for decreasing, or you can do INC to increase, then you can, basically, you're doing that to change the pre-selector. So if you need more or less quantity than the pre-selected amount, then you can do that with the rocker switch. Okay, and of course, when refueling is complete, there's a green end light that comes on. It's going to flash in case there's the wrong fuel pre-selection, or if when there was the automatic refuel going on, it stopped for some reason that's other than just normal operation, then obviously it's going to stop. So it's noticing something abnormal. Okay. All right, and just a little bit on the coupling and cap. The coupling, okay, that's the interface between the aircraft fuel tanks and your external fuel supply. Okay, so those are your refuel, defuel couplings. That interface between aircraft fuel tanks and the external fuel supply. Okay, and that's located to the forward face, okay, at the forward face of the right wing front spar. It's an L-shaped hollow body, and it's got a seal valve, your coupling ring. You got a compression spring as well as part of that. But chances are you'll just be replacing the coupling. Okay. All right, so on refuel, and this is on a manifold or gallery, however you want to call it. But there's an air inlet valve. That one's inboard face of a particular rib number. The pipe connects it to the refuel gallery. So that air inlet is what? It's letting air in. So let's air into the refuel gallery after the refuel procedure. Okay, so what is it doing? It's allowing fuel to drain from the refuel gallery through the drain valve. Okay. All right, so let's kind of go over a little bit on canisters And we've covered already sequence valves, air release valves, your cross feed, etc. So let's kind of finish out with talking about the canisters and what we need to be aware here. First of all, your refuel valves. Those have a manual override button to them. Okay, so if for some reason the solenoid's not working, you can manually operate the refuel valve. Okay. All right, so and as far as location for the refuel valve, talking about the wing refuel valve, that one is on the leading edge of the wing in the refuel valve canister behind a certain access panel. Now, the one for the center tank, that one's installed on the rear spar of the center tank, and that's also in its refuel valve canister. Okay. All right, so your refuel valve, I'm not going to go into that as far as the details on that. Now, just to know what kind of components or parts that you're, not so much what makes up the refuel valve canister, but kind of more how it's attached. So you get 4 screws and 4 nuts that join the canister body assembly to the check valve housing assembly. Okay, and that's what makes up the refuel valve canister. Okay, is that you have that canister body and the check valve housing assembly. Okay, so that canister itself, okay, that has an inlet port, an outlet port, and the mounting flange. That's for installation to the actual tank. Okay, now as far as the kinds of ports that they are, I mean, what kind of mounting that they have. You got square mounting flanges with the 4 holes for installation of the system fuel pipes. Okay, so 4 holes for installation, 4 threaded studs. Okay, in case you need it to refuel the, to install the refuel valve. All right. Okay, and you've got some rings. Obviously, your sealing rings can prevent fuel leaks between the refuel valve, the sleeve, and the canister body. So those are all part of that to prevent the fuel leaks. Okay, and just kind of a little bit on the defuel transfer valve and actuator. This is in the center tank, and it's gonna, when it opens, it connects the refuel manifold and the engine feed manifold for fuel transfer from tank to tank, or for fuel removal. So that's what that transfer valve is doing, and located in the inner tank. Okay. In this case, I mean, most of them that we have, they just have the one actuator, and this one actually has an actuator. Some don't, but most of them do, with the nature of the applications that we have with aircraft. Right. Okay. There's also, just kind of one more thing, there's also the overwing refuel adapter, and there's also the pressure relief valve there. So with here, the overwing refuel adapter, that's actually installed in the wing upper skin. So you've got an adapter nut with the locking plate that holds that adapter in the, in that spot, and you got the 2 O-ring seals that's going to seal the joint between the adapter and the wing and upper skin, right, to protect that. Okay, the lanyard attaches the refuel cap to the locking plate, so you have that. You got a pressure relief valve, so you got that as well. The mounting flange assembly, okay, is on the rib. I'm not going to name the rib number, but it's of the center tank. That's where you'll find that pressure relief valve. Okay, so and again, the parts, as far as just getting a visual on what they look like, just we have that available for you to see. Okay, so I hope that gives you a pretty good idea now, and familiarity, just kind of get in your mind some of the terminology, names of the components, what their functions are, the locations of the actual fuel tanks, And also just the heightened awareness of the critical design configuration that we have for many of the components that are involved in the fuel system. So that means you need to pay extra attention to what you're doing, because you're going to be following a certain procedure for the installation of those particular items. So just again, paying attention to wear and tear, or the wear, I should say, and damage to any of the mounts involved in installation of these components. Okay, indications. Always, want to be mindful of pressure at different points in the system, as well as temperature, and of course the quantity. Fuel quantity is important, and being very mindful when it comes to the refueling system. Okay, so that pretty much covers it. I hope you got a better feel for this particular system with this Airbus A320's fuel system. And if you have any questions, please reach out to us through email. We are going to have a review, so this is not going to be the first time you're going to hear this, or the last thing you're going to hear, last time you're going to hear about the fuel system, because we are going to go over kind of a comprehensive review of the entire GenFam. It's pretty intense, but I'm trying to get so that you can get familiar with the test questions as we go along in each of the topics. But the comprehensive review is really gonna kind of pound a little bit more into your brain some of this stuff. Again, we don't want you to memorize things. We just want you to take notes. Look at your handouts. The handouts are going to actually have the questions, so just pay attention. If we say, okay, here's what this is, well, then you just got that information, right? So write it on the piece of paper. Okay, hopefully you print these handouts out that have the questions and any extra notations that you want to make regarding your safe maintenance of doing of the aircraft. All right, so we look forward to having you listen in on the other topics.